In this application, we're going to be dealing with a financial situation where we want to see what happens with sales. 4 months after discontinuing advertising on national television, a manufacturer notices that sales have dropped from 100,000 MP3 players per month to 80,000 MP3 players per month. If the sales follow an exponential pattern of decline, what will they be after another 4 months? So I've got 2 ordered pairs here. And I'm going to do this just a little bit differently because I don't want you to forget about how powerful ordered pairs can be. So we've got our time that's elapsing, that's 0 months. And we've got our initial value of 100,000 MP3 players being sold per month. We have y equals c times e to the kt power. Whether we use y equals c times e to the kt power or a equals p times e to the rt power doesn't matter. What you need to understand is that when we're talking about interest, when we're talking about money and interest, so we would then use this value where time is in years. However, our input is months, our output is the number of MP3 players that we're selling. So we're not talking about earning interest here, so I'm going to revert to use this form of the formula, which is the same formula. You still have an initial value, an end value, a constant of proportionality, which is K. It's a rate at which sales are increasing or declining. And then, of course, your time. Now, time here, though, is dictated by the problem. Time in this case is going to be in months. So that's what allows us to use the time that's dictated in the problem is this formula on the left because we're not talking about compound interest. So what do we have here? We've got 0, 10,000, and then 4 months later, it looks like we've got 80,000 MP3 players being sold, right? So 4 months later, 80,000. So it's dropped from 100,000 to 80,000. So I'm going to use this formula. My initial value is 100,000. My end value is 80,000. And then I've got times E raised to the K times 4 power. And the reason it's the K times 4 power is because 4 months have elapsed. I'm going to divide both sides by 100,000. So I get 8 over 10. That's about the maximum amount of reducing I'm going to do. Divide by 100,000, cross out your zeros. I get 8 over 10 equals e to the 4k power. Log base e is the natural log of 8/10. I'm going to write that as a decimal. 8/10 equals 4k. Divide both sides by 4. And k equals the natural log of 0.8 divided by 4. Why do we need to do that? Because we need to go back to our formula and we need to put in the natural log of 0.8 divided by 4. We want to know what's going to happen in another 4 months, and then that's times t. So in another 4 months, what would t be? Would we really just put another 4 in there? Well, in another 4 months, I'm looking at 8, right? And I want to know what the value is 8 months after the initial. So we would not put another 4 in there. We think, oh, we just see a 4 and we're going to put a 4 in there. But you really need to think about the problem, and that's where writing your ordered pairs might be helpful. So we've got y equals 100,000 times e raised to the natural log of 0.8 divided by 4 times 8. I'm going to put all of this into my calculator, and I get approximately, it's going to be less than 80,000 because it's declining. Go ahead and put that in your calculator, and then take a look and see if that's what you got. So the whole idea is that they discontinued the advertising. And what happened when they discontinued the advertising? Well, the sales dropped. That makes sense. Advertise, you sell more. You don't advertise, and you're not going to have as many sales. So what happened 8 months later? The number of MP3 players per month, the number sold dropped to 64,000. 64,000. Okay, let's see if you can use this model in the example that we've just finished. This is our answer. Same exact model to determine when the sales drop to 50,000 MP3 players. See if you've got that. Okay. If you're ready to check your answer, you should have in your work the natural log of 1/2 divided by k is equal to time. And that time is the time that it takes for sales to decline from 100,000 to 50,000, and 100,000 to 50,000 is half the amount to half the amount started with. Now you can put all of the values in the way I did right here. You can put that value in, you can put that value in, and you can figure out 50,000 equals 100,000. You're going to divide by 100,000, you're going to get 1/2. Do all the math. This looks very familiar, and your time is approximately 12.425 months. Now, if you need to work really hard at the math, that's not a problem. I mean, continue to work hard and you'll make connections. Continue to have the exposure, take on doing some additional problems, and you'll be able to go right to this. You should be able to go right to this, or at least when I went right to this, recognize it and understand it. If you didn't, if you're not able to do that, then you still need some practice with exponentials and logarithms, and you need to give that to yourself. Don't rob yourself of getting that practice. Take it on yourself. You've lots of problems out there in a textbook, on the internet, reviews, all sorts of places where you can just do more problems. Some people just have to work a little bit harder to understand what's happening. So, with the numbers and with the math. So the time is approximately 12.425 months after advertising stops. So it takes a little bit more than a year, and their sales get cut in half. That's quite a big hit. So if they didn't intend for that, they're doing layoffs. Their business is in serious trouble. Serious trouble.